Hey there, let's learn today a little geometry. Transforming in math, especially in geometry, is where we take a geometric figure like a polygon or maybe a triangle and we alter its position or form. Basically, we make it look different or we move it to a different spot on a coordinate plane. And we're going to learn about three certain kinds that you could think of them with two different words. Think of it as reflection is the word for it, which is right here, which is really just flipping it, right? From here to here. It's called reflection. Then there's rotation, which means instead of sitting on this side, what if we rotate it and now it's sitting on this side, right? So it's really a turn, right? Okay, and then finally a translation is where we simply slide it to a new spot. Might be up a little bit like this one, or definitely to the side a little bit. Those are the three transformations. Let's dig into each one a little bit more. Here we have the reflection. It gets flipped across a line, maybe the y-axis here, right? So it goes from here to here, and when it flips, that means instead of the point C, being on the right side, now point C is on the left side. Because with a reflection, the key is to maintain the distance from C to the line. Notice how C is 2 units from the line with a reflection, with the original and the new one. And then the point B is 1, 2, 3, 4, 5 points from the center line of symmetry, reflection, whatever, in both. And A is 2 in both as well. In order to do this, on different sides of a line, the shape does need to be oriented different. So now you've got your right angle on the right side, in this case. A segment between corresponding points across this line is going to be perpendicular to the line of reflection. Notice if we folded along this line of reflection, folded the page, they'd line right up. They'd coincide exactly. Notice also, when it's a new shape that was created from an old shape, instead of calling it point A, now we use this little extra apostrophe next to it. When we go from, transform from A to the new one, A is now called A prime. And from B in the original shape to B in the transformed shape is called A prime. And C prime, right? You see that in all these light blue triangles that are created through transformation of the original. Positive rotation means we turn a shape counterclockwise around a point. If you imagine a point right here on letter B, it's like we're spinning it around to eventually end up back to where we were. So we've got our C prime, which was at the right angle, matches up with this original C, which is on the right angle. Notice the size of shapes doesn't matter. What we're changing is the way it's oriented or where it is. We're not changing size. We're not scaling it bigger or smaller. These are just transformations where we move it so it looks different that way. A translation means I slide it. I move it over. Just like that. Here we show a translation of 6, 1, which is 6 units to the right and 1 up. For any translation, describe the horizontal shift and describe the vertical shift for each point of the figure. What's the transformation in example 1? We go from triangle ABC to triangle A prime, B prime, C prime. Well, it's 1 up horizontally now, so that means there is a what did we call the slide again? Is that translation? Yeah, so it seems there's been a translation up a box, but it also looks like its right angle now is down here, and point C and point A are the bottom. Maybe it'd be easier to think of it as, looks like they had to reflect it too first. They reflect it over here, so it looks like this. It must be what they did. Then they turned it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then they rotated it back this way, a positive rotation so that it was lying on its side. Then they translated it up into the right, a unit, I'd say. So it looks like right away in example 1, they told us about, or they gave us every transformation, and here they are drawn out a little bit better. Looks like they had to translate 8 units to the right. So translation works better later on. When we don't change the size of the figure, the transformation is called an isometry, or a congruence transformation, because the original figure and its image are still congruent. But a dilation is where we change it so it's larger. Here's a dilation. We didn't so much change the way it's oriented or located, but just made it bigger, right? And a contraction, which I see a little bit less, but a contraction would mean going this way, making it smaller. Dilation and contraction, make it bigger, make it smaller. These are called similarity transformations because the measures have changed, the dimensions have changed. Why don't you try E, F, and G and use the last examples that I did not spend time on to help you get these answers if you need. Good luck.